Myself, Maitri Dave, Assistant Professor at LJ Institute of Engineering and Technology. Let us begin our lecture where we are going to discuss civil engineering materials. So here for plastic, I can say the first question that comes in our mind, what is plastic, right? Then we will see the types of plastic. Then we will move to the use of plastic, and lastly we will see the properties of plastic. So let us understand first what is plastic. So here I can say, as shown in this figure, it is a recent engineering material used all over the world, right? So plastic is a synthetic material made from a wide range of organic polymers such as polyethylene, PVC, nylon, right? That can be molded into shape while soft and then set into a rigid or slightly elastic form. So that is the concept of plastic. It is an organic substance, consists natural or synthetic binders or resins with or without molding compounds, right? So the plastics are polymers having higher carbon compounds with higher molecular weights. So we can say plastic is equal to organic polymers plus carbon plus oxygen plus nitrogen and the sulfur, right? So that is all for the plastic. Now let us understand different types of plastic. So here I can say different types are classified into two, in which the first one is the thermoplastics. It means I can say it becomes soft and melt on heating. It becomes hard on setting. It can be remolded again and again, right? It can be molded in any shape. So we can say, for example, nylon, polyethylene, polyester, PVC, all are the example of the thermoplastics. Now let us understand the thermosetting plastic. So here I can say this plastic when heated will melt and will become hard after prolonged heating, right? So this is due to polymerization reaction. After setting or curing, they do not become soft by further heating. So hardness is permanent, does not change on the heating, right? It is hard, strong, resistant to heat and electricity, and it is very cheap, right? For example, I can say the bakelite, epoxy and silicones are the example of thermosetting plastics. So that's all for the types of plastic. Now let us understand the uses of plastic. So here I can say for the uses of plastic, there are more than 10,000 different kinds of plastic available in the market, and their performance abilities span those of every other known material from soft rubber to steel. This typical use of plastic in buildings are summarized as follow. Like I can say for the bath and sink units, again for the cistern wall floors, or for the corrugated and plain sheets, or for the decorative laminated or moldings, right? Even for the electrical conducts, these are used. For electrical insulators, these are used. Even we can say films for waterproofing, damp proofing and concrete curing floor tiles are there. Even the foams for thermal insulations are still there. Even we can say the jointless flooring is also used as this kind of material, right? Even the lighting fixtures are also there. Even the overhead water tanks are also made up of plastic. Even the paints and varnishes and the pipes to carry cold water. Even we can say the roof lightings. Even the safety glasses. These all are the example. We can say the wall tiles and the water resistant adhesive are also still there. And lastly, different furniture items are also there. So these all are the uses of plastic, right? Now let us understand the properties of plastic first. So here I can say they are light in weight. Even they have a good resistance to most of the chemicals. They have a high electrical strength, right? They have good corrosive resistance. Plastic can be molded to any desired shape and the size. That is the advantage. They can be made transparent or color as per the requirement. They are cheap compared to metals. All operations like drilling, sewing, punching can be done on plastics, right? Even the paintings and the polishing is not necessary. Again, we can say the plastic possesses excellent electric insulating properties, right? The plastics have low specific gravity, the average being 1.3 to 1.4, right? So that is the property of plastic. So now for smart materials, I can say that smart or intelligent material are the material that have to respond to stimuli and the environmental changes and to activate their functions according to these changes, right? So the stimuli like temperature, pressure, electric flow, magnetic flow, light, mechanical, etc. can originate internally or externally. So I can say that we are going to discuss the classification of materials and the application of this kind of materials in detail. So let us discuss first the classification of smart material, right? So here the first type is all about piezoelectric materials. The second one is all about electrostatic materials. Third one is all about magnostatic materials. The fourth one is the shape memory alloy, and fifth one is the thermochromic materials, right? So these all are the classification. Now let us understand all one by one, right? So let us understand first. First one is the piezoelectric materials. Means when subjected to an electric charge or a variation in voltage, piezoelectric material will undergo some mechanical change and vice versa. Here on screen you can see different materials are look like this. So these events are called the direct or the converse effects, right? That is the concept of piezoelectric materials. Now let us move to the second one, which is all about electrostatic materials. So these materials has the same properties as piezoelectric material, but the mechanical change is proportional to the square of the electric field. So these characteristics will always produce displacement in same direction as shown in this figure, right? So that's all for the electrostatic materials. Now let us understand the third one, which is magnetostatic materials. So here, when subjected to a magnetic field and vice versa, it means the direct and the converse effect, this material will undergo an induced mechanical strain, right? So this kind of material is look like this, right? Now, if I want to give you a brief idea about the fourth type, which is of shape memory alloy. So here you can see in this figure that metallic material demonstrating the ability to return to some previously defined shape or size when subjected to appropriate thermal change belong to this category of smart materials, right? So here you can see how a building can get or how a material can get to its original shape. So that is the concept of shape memory alloy. Now let us understand the last one, which is thermochromic material. So as you can see on the screen that these are the materials which change their color in response to change in temperature, right? So they have been used in bath plugs that changes color when the bath is too hot, which is very good concept when we talk about the children who don't know that water is a cold one or a hot one, right? So these are the materials that we can wisely use and make our life better, right? So that's all for the classification of smart materials. Now let us understand the applications of smart material. So here for application, I can say it is categorized into three parts, in which the first one is all about smart materials in aerospace. It means the aircraft or the spacecraft which make use of smart materials are known as the smart structures. So we can say the smart materials are used in the aircraft construction, right? If I want to talk about the smart materials in civil engineering applications, then the smart materials can be used in the monitoring of civil engineering structure to assess durability. Again, which is very important. And lastly, if I want to talk about the structural application of smart materials, then smart materials are used for the development of durable and the cost-effective high-performance construction materials. So these are the applications of smart materials.